Let's get Jim Hoff up here to give his information that he's going to share with us.
One of the things that you might know about me is that I was a computer designer, and so information is very important in what I do. We would do things like data compression. We don't do much data compression on CDs anymore because we have so much space on them that you can't even fill them, so we don't compress. But back when we had small memories, you had to compress the data. In order to do that, we had to know about what information is. What is information? Anybody want to give me a definition of what information is?
Tell you the instructions, I would say.
That'd be one way to, what Wikipedia says? It's that which informs. Okay? Information is that which informs. And the way that they describe it is, it's something that reduces uncertainty. It provides a surprise factor. When I tell you something that's information, it provides a surprise factor. If I were to tell you, you already know my birthday is July 4th, but if I were to tell you my birthday was March 13th or something like that, you'd go, oh, that's interesting. But if I tell you my birthday is July 4th, you're surprised because your chances of having a birthday on July 4th or Christmas or New Year's is only 1 in 365. If I know a couple people whose birthdays are on February 29th, that means that their birthdays are 1 in like thousands of possibilities. And so the more surprise factor it provides, the more information that you're getting. That's what information is. Information surprises you. It tells you something that you wouldn't have otherwise already known. Well, information is always being lost by natural processes. If you take a newspaper, and maybe this newspaper's got a bunch of typographical errors in it, because newspapers do. Sometimes, maybe on the sports page, they'll give them the wrong score for something like that. Put it outside for a week or 2 or 3 weeks, let it get rained on and washed and the wind blowing and everything. Is it going to come back with the right scores? No, it's not, because random processes never increase the amount of information. They always reduce it. The reason why is because information is surprising. It's not what you would expect. And so the random processes will always produce expected things. And the reason for that is that there are many more ways that things can be expected than there are for them to be unexpected. You go into your child's room, you got a teenager, and a sock is hanging over the bed, and the bed's unmade, but it's a lot of ways to unmake a bed. It can have the paper, everything in different places. A shoe over here in a corner, and a mess, a dirty bowl, and things like that. Or what if you went into that room and everything was in its place? The pillows were carefully tucked in. Yeah, that'd be a miracle. You could flip a quarter on the bed and it would bounce, and all the shoes where they were supposed to be. The reason why that's surprising is because there's only one way that can be, or maybe a few ways that can be. Most of the ways it can happen are unsurprising. If an earthquake comes and shakes and rattles the room, or you let your kid into the room and let them just be in there for a while, it gets into a more a less surprising state because there's so many different states. Well, information is surprising. So when we say that information is increasing, see, evolutionists say that information is increasing, right? There was one time when there was no information in the universe at the beginning of time, they would say. But then something happened that caused this information to get there. They would say that a life form formed and started producing offspring, and those offspring slowly increased the amount of information in the DNA until now we have us, with a huge amount of information in our DNA. Well, that goes opposite of what we know about natural processes. Natural processes always destroy information. They always that law is called the entropy law. Now, most people know of entropy as being thermodynamic entropy. That we talk about what's called useful energy. If this whole room were lukewarm, you couldn't do anything. It's got energy because warmth is energy, but you can't do anything with it because in order to do energy, you have to have a hot and a cold, and then you use what's called a heat engine to take the heat from the hot part, put it in the cold part, so they both come lukewarm, and you can run a machine from that. That's what happens. But time automatically does that. Time is always destroying energy, useful energy. It's also always destroying information. So what that means is that if you were to go, I'll tell you one more thing, and that is that information is improbable. Maybe I already said that in a way, But the way that you can talk about, the way that the law of entropy says, is that things always go from the improbable to the probable. Now that makes a lot of sense if you think about it, because what you're saying, what's it going to be like tomorrow probably? Well, it's going to be such and such. Well, when that happens, then we're going into the probable state, the one that we thought was going to happen. Information is always going from the improbable to the probable. Well, let's turn around and go backwards. That means that as you go towards backwards, what happens to the probability of the universe? It goes more and more improbable. It goes, you're going to the probable this way, forward, you're going to improbable that way. If you go back all the way to the beginning of time, and by the way, there is a beginning to time. Did you know that? Time had a beginning. There was a time before which there was no time before that. All of us agree on that. Evolutionists, creationists, young Earth, old Earth, everybody agrees now that time had a beginning. There was a time when there was no time before that. So let's go all the way back to time zero. How much information was there at time zero? Well, as you go back, it's more improbable, and improbable means more information, right? Isn't that what we were just saying? Improbability is a surprise factor. It's not likely that my birthday would be July 4th. And so when you find out that's the case, you're, oh, really, that's interesting. Well, what did you get for your, wasn't that something when you got the fireworks and everything for your birthday? But and so the more improbable it is, the more surprise factor there is. And as you go back in time, it gets more and more improbable, so that the most improbable state that the universe ever will be in or ever was in was when? Or will be when? The beginning of time. At the beginning of time was the most improbable event that ever happened. Now think about that for a second. That's a miracle. That's the universe came into being in the most improbable state, and it's been going towards the probable state ever since then. That doesn't make sense for DNA being accumulated. God made the universe with all the recipes, all the likelihoods, all the things that have to be there right at the beginning, and then it's been falling apart ever since then, or at least since the fall. Maybe it wasn't falling apart before that, but ever since the fall, things have been going downhill. Now, that's the end of the story. Talk to someone who knows a little bit of math and physics, and tell them and ask them about that. When you go back in time, things get more improbable, right? And as you go forward in time, they get more probable. At the beginning of time, which we all agree there was a beginning to time, that first event, which often people call it the Big Bang, that brought the universe into its most improbable state. Now, think about that. What that means is, for instance, if I were to make this Big Bang and my laptop came out of that bang, you say, you can't have a laptop come out of a bang. Laptops are explosions. They cause destruction. But the evolutionary, what we know about science now, says that the first event was the most improbable event of the entire universe. And it's been becoming more and more probable ever since then. And by the way, if I have a universe that's in its most probable state, but I bring one thing into it, my cell phone, which is very improbable, right? It's got all kinds of engineering and all kinds of stuff. I just changed the state of the universe. The universe is now more improbable because I've got the cell phone. Or if I write a poem, or if I generate something out of somebody just out of intelligence and makes something up, they change the state of the universe. But the universe had to be in its most improbable state, according to natural laws, at the beginning of time. Now you're violating that if you are a human thinking and you're producing and you're creating something, because you're creating information out of nothing. You're creating information where there wasn't information. Evolutionists would say, no, that's not the case. You are, nothing that happens in you is special. All you're doing is just running these chemical reactions. But no, that's not what's happening. You're creating information. You're creating improbability. Now, maybe that means something to you, or maybe it doesn't. But realize that that's a smoking gun. That's the end of the story. In the most improbable state that the universe ever will be in or ever was in was at the beginning of time, and all the things that we know about information is that we're losing it. Okay, that's I think that's a really something. Just go home and chew on that for a while, because it really means these kinds of questions have been things that we've been dealing with for a long time. We've got a couple minutes, so let me just explain a little bit more about the entropy thing. Entropy is the probability of a large system when looked at from a large state. For instance, if I had 1,000 coins and they're all jumbled up, I shake them in a jar and they all fall. And how many coins are going to come up heads and how many are going to come up tails?
Theoretically, 50-50.
Yeah, somewhere around half and half. You might get 499 and 501. You might get, but you're not going to get 0 and 1,000. You're not going to get or one head or all tails, for instance, or all heads. Why? Because your chances of that happening, you have to have this one go into an improbable state. That one has to go into an improbable state, and that one, and that one, and that one, and that one, and that one. And each one is a factor of 2. You got 2 states to the head. It's got heads and tails. So when it lands on, say you're going to make it be all heads, you got only half the time could that head land on a head. Next one lands on heads. That's a quarter of a time. Next one's an eighth of a time. Next one's a 16th of the time. And what it is, it ends up to be 2 to the 1,000th power, which is about 10 to the 300th power, somewhere in that range. 10 to the 300th power, the chances, you will never, ever, ever shake a jar of 1,000 coins and have them all come up heads or all come up tails. Because there are many more states that they can, the way that they can come up 500 heads and 500 tails is huge. You can have, all the different ones, you can toggle them, and you can have many different ways that it can come up heads and come up all half heads and half tails. Okay, so things will always gravitate towards the random, the medium state. Now, just real quick, so you get an idea how that works. Take the number 1, and then down here put 1 and 1, and then you go 1 and 2. Add the 2 ones together, you get a 2, and you get a 1, and then you get 1, 3, 3, 1, then you get 1, 4, 6, 4, 1, then you get 1, 5, 10, 5. You know what I'm making here? It's a little thing where you take a ball and you drop the ball, and it randomly falls, and it goes. The way where it's going to fall is going to be the numbers I'm just giving you are where they're going to land after that many falls. So most of them are going to land in the middle somewhere. The one down these edges are always 1. In order for this one to come down to that'll be the 1,000 here, and it's got 1 chance out of all those 2 to the 1,000th power things. Down here is 1, 1, 1, 1, 1, 1. In the middle, it's going to be it's going to be very, very large. I couldn't even tell you what the size of the number is. But you see what's happening? Things always will go towards that middle value, and you won't make something special by random forces. That's what evolution is saying. Evolution is saying that just by chance you're going to get this thing to grow and grow and grow and grow in information. That's not what happens. And one way to show you that that's true is to ask ask a scientist, a secular scientist, what the world's going to be like in 1 billion years from now, 2 billion years ago from now. They'll tell you we're going to suffer heat death. We're all going to die. That's a guaranteed thing. Everybody would agree if we were going to go around for 1 billion years, everything would fall apart. We would all become genetic junk, and the universe, all the heat would get distributed, and we suffer what's called heat death. They believe that, but then at the same time, they believe something that's just the opposite. We're going uphill. We're not going uphill. We're going downhill. God made us perfect. I want to say perfect, ideal, it may be a better word, would be the best that we could be. And then Adam and Eve had their kids. They each got 100 mutations, and we're starting on our way down this track. The next ones get 200 mutations, and they're all bad, just about. There's almost no chance that anything good. So we are now living around 100 to 200 generations, somewhere in that range. There are some people who actually know how many generations they are from Adam. Because they're near the king and queen, and so they can go down. I think someone is like they're 87 generations from Adam, and in that amount of time, every generation gets 100 mutations about, and so that's 87 times 100 to be 8,700 mutations, and they're all bad. So we still function and everything, but that's why we've got so many genetic diseases, and children are born with all kinds of childhood diseases and so forth, is because our system is breaking down. I doubt there's everybody here has allergies. You know what an allergy is? It's a breakdown in your immune system. Your immune system was very specially finely tuned when God made it, so that you would be immune to this and this and this and this, but not to other things. One of the things you're not immune to is yourself. If you're immune to yourself, it's called an autoimmune disease. And people have autoimmune diseases where their body is trying to kill them. Their immune system is trying to kill them. I'm immune to grass a little bit, and probably allergic to grass a little bit. And everybody's got these little allergies. Those are your system falling out of tune, and so we have all these problems. Do you see what's going on here? We're believing a lie. We're believing something that if you just stop and think about it, just would not be the case. Don't think that God didn't give us evidence that He's real. God gave us powerful evidence that you can find in the mathematics, you can find it in physics, you can find it in all these different areas of the fact that God is real. And that's one of the things that many people are driven, like myself, to believe in God because of what He's shown us in His own in this creation. So that's basically what I wanted to say.
Very good.